Yes. Okay. Hmm. So how should we? Okay, so let me don't waste any time further and work in this only. Right. So in this chapter, we will learn about the as application or you can say results of all the forces that you have learned in the previous chapter. So one result is what the work done. Right. And then you will learn about, as the chapter suggests, we learn about the energy. And in energy, and you have two kinds of. So we'll focus only on the mechanical energy, right? There are two kinds of mechanical energy. One due to the position, the orientation, or the conservative force, and the other one due to the motion of the body. So due to motion, you have kinetic energy, and due to conserved forces, you have what? Potential energy. Right, then we will learn about the relation between the kinetic energy and the momentum of the body. Right, and then in potential energy, we will learn about the conservative force and different kinds of conservative force. So one is what, as you guys have told, gravitational force, right? And the other one is the spring force, right? And the other one is what? Electrostatic force, but we'll discuss only these two, right? And then we will learn about the equilibrium. And in equilibrium, we will learn about the stable and unstable, right? And then you have a constant equilibrium, right? So these we will learn today. We will try to reach up to this point, right? So first, how should I move this up? Yes, thanks. So now let me change my favorite color. Okay. And then, right. So let's say you apply some force. So let's say this is an object and you apply some force on it, right? Or from this side or any side. So you apply some force and it displaces. So this is, let's say, and its mass is m, and then it displaces from here to some distance x to here, right? So you make the body move from here to here. So then you will say that you have done some work, right? So first thing is, what is the work done, right? So the work done is defined as the dot product of the forces applied and the displacement that occurred, right? So this is the displacement and this is the force that you applied. So as you can see that it is a scalar quantity, right? Right. And its dimension is like energy, so its unit is joule, right? So there are two kinds of is that you have a constant force, right? And then you have a variable force. Constant force meaning that let's say in vector form you have 3i plus 4j plus 3k, right? These kind of forces. So yeah, this doesn't depend upon the position on anything, not the time, nor the position, right? So it doesn't change. So this is a constant force. And then in variable force, let's say your components are varying, right? So this fx is constant, fy is constant, fz is constant, right? But let's say your components are varying. Let's say you have x square I plus y z and let's say j and then you have what? Z square k hat, right? So you see that your components are varying. So this will have some variation. So let's say this is what? Some let's say R and this is some force, right? So this is a varying force, right? So you define the work done with respect to these two. So your work done for the constant force will be the same. So for constant force, you have work done will be simple Fs cos theta. So F dot S you already know this is what? Fs cos theta, right? So this is, let's say you apply some force and this is the angle, right? So, and this displaces some body. So the angle between the displacement and the, let's say, so let's say this is theta, right? Not this angle. So angle between the displacement and the force is like this. So this is the angle between the force and the displacement, right? But when you have a variable force, right? So what will be the for variable force? So what will be the work done? So the work done will be F dot dr, right? And this goes from whatever is the dimension. So let's say you have, let's say this is the position vector, right? So your dr will depend upon the dimension, right? So let's say you have a 1D object, right? Or your position is one dimension, right? So then your dr will only be dx, right? Dxi hat you can see, right? So this is for 1D. And let's say if the body is or if the force is acting in the two dimension, right? So you have displacement in two dimension. So dxi plus dyg, right? So this is in 2D. And if you have the displacement in the three dimension, right? So if you are in a plane, so then you have two dimension, or if you are in a straight line, then you have one dimension, or if you are in a volume, right? So some, let's say this distance, then you are in 3D, right? So this will be dx plus dy, and then you have dy, right? So this is in 3D. Okay. So your F dot dr will be a single integral, right? What do you say? So this will be a single integral when you are in a one-dimensional displacement, right? So this will be only f is what? Fxi not, and then fyj, and then fzq, right? And then your dr is dxi plus dyj plus dzq, right? So if you are in a three-dimensional system, then your integral will be what? A three integral, right? So this will be what? Fx dx, right? Not the three integral. Let's say, so this will be what? Fx dx, this multiplied by this, and all the other are zero, and then you have fy dy, right? And then you have fz dz. Right. So this is the work done for the variable forces. Okay. So let's do some question based on only these two topics. Right. So am I clear to everybody? These are just trivial. What should I say? Trivial lesson that you have already learned in your classes, 11th classes. Right. Am I clear, everyone?
Yes, sir.
Okay. So let's say you have a force like this, right? And it acts on a body due to which it displaces from this to this. So we have to calculate the work done. So let me copy this and then, oh, so this was 231 and this was 542. Okay. So let me copy this. Okay. And let's, okay. 3i plus 2j plus 3k. This is what? Marita, this is what? I don't understand. Mm, okay. Work done. Sorry. So work done is a what? Scalar or vector quantity,
Oh, okay, scalar quantity.
right? So it cannot, it can never be in this form, right? It will be some number, right? Okay. If this is a
Yes.
constant, if this is a constant force or a variable force. Hmm?
Constant.
Yes, so this is a constant force, so we should apply this one, right? ds is the displacement, right? And if this would have been what? The variable force, then we should apply this, right? So let's say R1 to R2. Okay, root 22. Okay, right. So let me calculate first. So this is the position that it has displaced from. So firstly it was here. So let's say 231, right? So this is let's say x, and this is y, and this is z, right? So in X, you are what? 2, and in Y, you are what? 3, right? And in J, you are what? 1. So let's say this point, right? So this is 2, 3, 1. Okay. And it displaces from here to 5, 4, 2. 5, let's say 5 is here, 4 is here, and 4 is here, and then here, right? So here. So this is B, right? So what will be the position vector of A? This should be 2I and 3J plus K, right? This is the position vector of RA, right? And this is the position vector of RB, right? And this is the displacement, right? So this is the vector. Okay. So what will be the position vector of B? Guys, help me.
5i cap plus 4j cap plus 2k cap.
Right. So 5, 4, and 2K. Right. So what will be the displacement? Let's say this is the displacement. So this will be what? RB minus RA. Right. So this will be what? 5 minus 2I. This is 3I. And this is J. And this is what? K. So this is the displacement. Right. So this is the displacement vector, right? And the force is what? I plus 2J plus 3K, right? So you have the force, you have the displacement. So work done will be what? F dot S, right? So these are in what? In the Cartesian coordinates, so we don't have to bother about the theta angle, right? If this would have been in the polar form, then so let's say if you had magnitude of F was 2 Newton and magnitude of S was 3, let's say, meters, and then the angle between them was, let's say, 45 degrees, then we should apply Fs cos theta, right? So this would have been 2 into 3 into cos 45. So this would be 6 by root 2. So this is what? 6 root 2 by 2. So 3 root 2. Right. But these are in what? In the Cartesian form. So we should not bother about the angle here. Right. So yes. So F is what? I plus 2J plus 3K, right? And dot 3I plus J plus K. Right. So this would be what? I dot I is 1. So this is 3 plus 2 plus 3. Right. So this is what? So this is 8 joules. Right. So this is the working. Clear everyone? Am I right? Guys,
Yes,
why are you guys? Yes. So why are you guys so silent? These are some trivial things, right? These you have already learned in your classes, previous class. Right. So let's take one question if you have. So this was for the constant force, right? So are you guys noting down or what? Do you guys note down or what? Because I scroll fast if you are doing that. So if you guys are noting down, then I will wait, or if you're not, then I will. Guys, hello. Okay, so
Done, sir.
okay, right, right. Okay, so the next question is about when you have a what? A variable force. So let's take this question. Or let me take one more question and you see if you guys. So this is a very simple question. Yes. So right. So take this question. Right. This one. So this is a similar kind of question, right? So you have position vector R, oh sorry. So the position vectors are given, right? Yes. So position vectors are given, minus and so this is what 4j plus 3k. Right. So what will be the displacement? So let's say this is this is R1, right? And this goes from here. So this is R2, and this is the displacement vector, right? Which is what? R2 minus R, right? Okay. C. So only Malta is responding, and all other people are silent. What have you eaten, guys? Hmm? So we are in the chapter which talks about energy, and and yours energy seem to be what depleted or what? So please respond, guys. Be energetic because we are learning about energy, right? Okay. So this is displacement and what should be the displacement 4j plus r1 minus what minus 2I plus 4j plus 3k, right? So 4j plus 3k and this is 2I plus 5j. Right, so this is how much is minus 3k and this is what? 3k. Right, so this is the displacement, which is S, right? And Marita has found C to be the answer. Okay, and what is the force? So force is what? 4I plus 3j. Right, so work done will simply be what? F dot S, which is 4 into what? 3, this is minus, so 3, so 5. 5. Right, Maida. So this is the right answer. Right. Okay, so let's one question where your force is not a constant force. This question. Okay. So let me take this. Right. So here the force is what? Variable, right? Right, guys?
Yes,
So,
sir.
so whenever your force is variable, right? So you don't calculate the displacement vector like this, right? So you don't calculate R2 minus R1, right? This is the limit of the integral, right? So here I will talk about this later when you have the integral. So what formula we should use? So work done will be what? F. So F is what? 6xi plus 2yg. So force is what? Two-dimensional or three-dimensional or what? One dimension.
Three-dimensional.
Guys. Guys. Force is what? Two-dimensional or three-dimensional or one dimension? Yes, right. Three-dimensional. Three-dimensional? So you have only I and J, right? X
Sorry,
and Y.
two-dimensional.
So this is two-dimensional, right? So you have two dimensions. So your dr will be what? Dxi plus dyj only, right? Right? Am I correct? So this will be dxi plus. So you see that this is x1, right? This is y1, and this is x2, and this is y2, right? So the integral will be only the I and I will survive, right? So this will be what? 6x dx, right? And this survives, this and this gets cancelled, d0, 2y dy, right? So in here we will take what? The limits of y. So you see that this will be y1, y2, and this will be what? X1 and x2. Right, guys? Because you are. Am I correct, guys?
Yes, sir.
Hmm. So yes, so you have x1 is what? 3, and x2 is what? X2 is what? 5, and your y1 is what? 8, and y2 is what? Minus. This will be from 5, and the lower limit is what? 3, right? So this is C, 6x dx and 2y dx. So this is the final integral that we have to calculate. So this will become 6 goes out Hello.
Yes, sir.
Yes, sir.
Am I audible, guys?
Yes,
Yes,
sir.
sir.
I'm sorry, I got disconnected somehow. So my network is fluctuating and I got disconnected. What is happening? Sorry about that, guys. So my internet is very unstable and okay. So video is also not working. So from where I got. Hello, guys.
Yes, sir.
So from where I got disconnected, can you guys tell me? Let me share my screen. So from where I got disconnected, please tell me. Anyone? Guys. Uh, so Yasu has W equals to 0. So as I was telling that, guys, am I audible? Hello? Hello?
Yes,
Can
sir.
anybody unmute himself or yes, so please tell me. So where was I? Hello guys, am I audible?
Yes, sir. So you were solving this question. It has two dimensions.
I don't know what is happening.
So your voice is lagging a lot.
So my internet is yes. So let me join with what? This is hello.
Yes,
W is
sir.
96. Okay. Yes, thank you, Sanya and Arpit. So as I was sorry about the network problem, right? I don't know what is happening with my network because I'm not in my office right now, and from here the internet is not working properly. So I was doing this work done for the variable force, right? And as the force was in 2D, so I used this form of dr, right? And then I reached here, right? And then I applied the limits of the integral. So I was solving this. So this became, did I got disconnected again?
No, sir, we can hear you.
Right. So sorry everyone for this interruption. Right. Okay. So as this is what? Minus 4 square minus 8 square. Right. So this will become what? So this is 25 and this is 9 and this is what? 16 and this is what? 64. Right. So this becomes what? 16 and this becomes what? So 64 and this is. So this is minus of. So this is 0, right? Okay. So Moita, your first answer was correct, right? Or did I do anything wrong in here? So you can see that it is going from the positive to a negative direction, right? So that is why
Oh, okay, sir. Yes, I
it
took
is
the limits in the wrong direction, in the
right.
wrong way.
Yes, so your final limit is minus 4 and your initial limit is 8, right?
Yes,
Because
sir.
so this was the final position of that object, right? So this is how you calculate the work done for the variable forces, right? And let's say if you have a force or a displacement which is not in either of these two forms, right? So let's say you have a displacement which is in the parametric form, right? So your x is varying with time, let's say, right? X, Y, and Z are varying with time. So let's take one variable only for this. And let's say your X is a function of T, right? Then what you do, then you change your integral. So you change your integral to the, so this is f dot dr, right? You change your integral to some dt, right? Understood my point? So in the previous questions, in those previous questions, we learned that your force is either constant and force is variable, right? Now let's say your force is in some parametric form, right? Then what you will do? So let's take one example of that. Okay, so let's take this question. So let's take this question. Here you see that your displacement is in the parametric form, right? So in this previous question, your force was is in the function of the positions, right? X and Y. But you see that now this X and Y's are also the functions of time. So these are in some parametric form. Okay. So now what you will do? So for these kind of questions, for these type of question, what you do is that your force will be, your work will be again as the variable form, right? And you can calculate F from here. So you have given the mass, right? So you can calculate your force from this, right? And this is in one dimension, right? X, so you can write it as F, X, right? So this will be Fx dx, right? So your F will be what? Mass is 1 kg, so 1 into and A is what? D square x by dt square, right? So you can calculate F as a function of T. Right, so this will be what? So your x is t cube by 3, right? So your velocity will be dx by dt, which is what? 3t square by 3. So this is t square, right? And then you have the acceleration, which will be what? D square x by dt square, which is what? dv by dt. So this is what? 2t. Right. So F will be what? F will be mass into acceleration. So 1 into 2t. So this is 2t. Right. This is force and this is the velocity. Yes. 5J. Again, so we are calculating the work done, right? So work done is a scalar quantity. So your answer cannot be in some unitary vector forms, right? So let's put those values in here. So your force is 2t, right? So your work done is what? 2t, and this is dx. So what we can do is that this is in the function of t, right? So we should change this integral with respect to what? Dt, right? And what should we do? We should multiply this by t and multiply this by t and divide by t, right? So this doesn't make any difference, right? Right, guys?
Yes.
Okay, so dx by dt will be what? This will be v, right? And this is dt. So now we have changed the integral in the form of dt, right? So this is now correct. And we can write v as function of t. So all the integrals should be the form of in the form of t, right? So v is, we have already calculated. So v is what? T square. Right. So this is dt. Now this is making sense, right? Right, guys?
Yes,
Am I
sir.
right? So only Sanya, Arpit, and what? Marita are responding, and all the other people are silent. I don't know why. Did I do any mistake, or did I, or what should I say? So this is 2 cube and dt, right? So we should know about the limits of this t, right? So again, you see that in the question, they are asking about the work done by the external agent for first 1 second. So it started from, let's say, 0 second, and from 1 second, right? So your limit is what? 0 to 1, right? So your limit is given, and now we can calculate the integral, right? So this will be, so this will be what? 2 and t4 by 4, and the limit is 1 to 0, right? So this will become what? 2, and this cancels, so we can take 1 by 2 outside. So this will be what? 1 4 minus 0 4, right? So this is 1, so this becomes half, right? So half joules, right, guys? Am I correct? Any question in that? Any question, guys?
No, sir.
Right,
Can you
Maita?
show the question for a second?
Okay, okay. So you are given the displacement or in the parametric form, right? So
No, sir,
the,
actually it is 5 joules, sir. I wrote it as J.
huh? Sorry. This is 5J.
No, sir. You were asking like, no, I gave the answer in vector form, but sir, it was not a vector. It was J stands for joules.
Okay, so you wrote J. Oh, sorry.
Yes, sir.
Sorry.
That was 5
I-
joules. Sir.
Okay. So 5 Joule.
Yes, sir. I'm recalculating again, sir. Like, let me check.
Okay.
I'm done.
Yes, please check that. Did anyone else solve this problem? Anyone? Okay, I wanted to do up to equilibrium, right? And we are doing only the work done for the constant force and for the variable force and for the parametric form of the forces, right? So we did only 3 topics. So in the next class, I'll be completing. Okay, let us see how far we can go. Okay, so Arpit, did you check?
Sir, I'm doing the question from the start, sir.
Okay. So you please go ahead and tell me if I'm correct or wrong. Marita, did you try also?
No, sir, I was actually doing it along with you. I couldn't do it otherwise.
Okay. Okay, so did you find the answer? Am I correct or wrong?
Sir, I guess this is the answer.
Okay. Okay, anyone else? Sanya, Namira, and Iram is there. Abhinav, Anna. Why are you guys so silent? I don't understand. These are what? Trivial things, right? Okay, so Arpit, let me go ahead and you please tell me the answer, right? So far we learned about what? So please keep in mind that if you have a constant force, right? So you will apply work done as F dot ds, right? And if you have some, let's say, variable force, then you apply what the integral form, right? So F dot dr, right? And let's say if you have a parametric form, and the parametric form is with respect to time, right? So you apply. So this is F dx, right? And you can change dx to be like this. So this will be what? F v and dt. So you write f and v as the function of time. So this is the key idea to calculate the work done, right? And in the next, okay, I will just please give me what 5 minutes and then I will complete the kinetic energy. So the next topic is the energy, right? And as you guys already know that this is what ability to do what, right? So this is how the energy is defined. And in this chapter, we will learn about the mechanical energy. Right. Mechanical energy has 2 forms. One is the what? Kinetic energy, and the other one is what? Potential energy. Right. This comes due to the motion of the object, and this comes due to orientation or what do you say? Position of the object. Right. This comes due to conservative force. Right. So what is kinetic energy? So if you have a moving body, right? So let's say this object is moving with velocity v1 and it reaches here because some force is applied, right? So let's say this mass is m and this mass is m. So the kinetic energy is defined for this particle. Let's say the kinetic energy will be half mv1 square. Let's say if you have a moving body which is moving with velocity v, so the kinetic energy is defined like this, right? And there is no theoretical explanation that why should this be half mv square. There is no any theoretical explanation. This comes from the experiment, right? So you plot the velocity and you plot the energy diagram, and you see that this is some parabola. So let's say this, like this, right? So this is how, and you measure the velocity, right? And the slope comes out to be v square half mv square, right? So let's say you plot v square here, and you plot here, and the slope comes half m. So this is the kinetic energy. So this comes from the experiment, right? Why shouldn't be there half mv cube or half, or let's say mv, right? Mv is momentum, right? So this is how you define your kinetic energy, right? This comes from the experiment. So you can also check the dimension. Okay, yes, right, okay. So I've already taken your 3 minutes. So the kinetic energy is defined like this, half mv square, right? And you can check the dimension of this, and this will come out to be in joule, right? So the energy dimension. Okay. So let's say you apply some force, right? And the velocity of the object, if with which it was moving, was v1, and then it becomes v2, right? So what will be the work done here? So work done will be what? F dr, right? Or let's say dx, right? And we can write F, we know. So this is, you see that this is in velocity, right? This is in velocity. So our aim should be that the integral should be in the form of what? So we know that this is the initial velocity and this is the final velocity, right? So the integral should be in the form of, you know, the limits of velocities, right? So the integral should be in the form of what? Marita?
In the form of fx dx by dt.
In the form of velocity, right? So this should be in the form
Yes.
of dv, right? So this is our aim, right? And how can we change that? So let's say your f is what? Ma, right? And this is what? M dx, or let's say m dv by dt, right? So we got dv, right? So let's put that value in here, which is our goal. So this will be what? M dv by dt, right? And this is dx. So dx by dt will become what? This will be v, and this is dv. Right now, this integral looks good, right? So the function is v in the form of v, and integral is with respect to v, right? So this seems correct. And what are the limits? So v1 and v2, right? So this is the limit. So what will be the integral? So w will be m and v square by 2 in the limit v2 v1. So this will be what? Half mv2 square by 2 minus v1 square by 2. Right. Okay. So this will become what? Half mv2 square and half mv1 square. Right. So this is how much? So this is half mv2 is what? K kinetic energy final, and this is what? Kinetic energy initial. Right. So this is called the work energy theorem. Right, guys? Understood my point?
Yes, sir.
Okay, and the next part that I wanted to talk about is what is the relation between the kinetic energy and the momentum. Right. So any question in this part? Anybody?
No, sir.
Right. So let's say from here, if you have kinetic energy, the final kinetic energy is, let's say, if you have Kf is greater than K initial, right? So your final kinetic energy is greater than initial kinetic energy. So this is greater than this. So work done will be what? Greater than 0, right? So you say that your object was moving with some velocity v1, and then you applied some force on it, and then it moves faster, right? So then your work done will be positive, right? And let's say if you apply the force and this kinetic energy final is less than the initial kinetic energy, right? So the object was coming in your way and you hold that object for some time, right? Then the final kinetic energy is less than the initial kinetic energy, then your work done will be negative, right? Okay. Right.
Yes, sir.
So what I was talking, yes. So the relation between the kinetic energy and the moment. So your momentum is what? Mass into velocity, right? These are all in the magnitude form, so don't bother about the vector signs, right? And your potential kinetic energy is what? Half mv square, right? So let's multiply with m and m here, right? So this will become what? Half m square v square by m. So this becomes mv square by 2m. So this becomes p square by 2m, right? So your kinetic energy is related with momentum like this, right? So that is why you will see that your total energy sometimes is written like this, plus half, or when you have a gravitational potential energy, then you will see mgh, right? And if you have some spring constant, then you will see that this is half kx square. So this is how you will see not the kinetic energy, the total energy. So this you will see after some time. Okay, so this is how your kinetic energy is related with the momentum, and you can write your momentum like this only. So this is 2m k and v, right? Understood my point?
Yes, sir.
Okay, so do I have any question based on this? Please let me see, and then yes. So this question: momentum of a body increased by 10%. So momentum of a body is increased by 10%, and we have to find the change in kinetic energy, right? So uh, let's copy this question. Hmm, what is that? Uh, what is that? Okay, so did I not selected this question? What is fine? Yes. So this is an easy question, right? 1.21 times. Yes. Mm, okay. Sorry about that, guys. My internet is not working. So let me. Okay, sorry about that, guys. Okay, so change in 21%. Let me see. So your, let's say, initial momentum was P, right? So the final momentum or the P prime will be Muhammad Irshad. I don't know. So your P prime will be a body of is increased by 10%. So P plus 10% of P, right? This is how much your P prime has changed. New P prime is what? So for this P, the kinetic energy was what? P square by 2m, right? And for this P, this is what? P plus 10p by 100. So this is what? So this becomes 10, 11p by 10, right? So your new kinetic energy will be what? P prime square by 2m. Yes, 21%. Yes. So let me check. 21%. So you are calculating the percentage change, right? So percentage change. Okay, so P prime is what? 11 P square by 2m. So this becomes what? 121 P square by, this is 100, and this becomes 2, let's say 100 into 2m. Right. So P square by 2m is what? 121k by 100. Right, guys? So you can see that this is how much. So your percentage change will be what? K minus KE by KE into 100. Right, so this is the percentage change. So 121 K by 100 minus K, let's say by K, and then into 100. So this is 21K by 100K into 100. Yes, so this is 21%. Right, so Arpit and Marita got the right answer. Right, guys? Okay, so
Yes, sir.
right. So what was the other question? Let me see, and then